So in calorimetry, we're going to be looking at the measure of heat changes. What's the symbol for heat? Q. Symbol for heat is Q. Q has signs, positive and negative. Remind me what the positive and negative mean for Q. Right, if the system is losing or absorbing, right? And the system's what we're interested in measuring. If the system is losing heat, then Q has what sign? Negative. If the system loses heat, Q has a negative sign. If the system is gaining heat, then Q has a positive sign. And when we introduced that, we also talked about the first law of thermodynamics, which says that energy is not lost or created, it's just transferred, right? So if the system loses the heat, then Q would be negative. Well, where's the heat going? To the surroundings, so Q of the surroundings would be positive. Same amount, just different sign. The sign of Q also tells us exothermic or endothermic, right? Exothermic means it feels hot. That means Q would be negative. Endothermic means it feels cold. That means Q would be positive. And all that stuff that we just got finished saying and summarizing, y'all need to have that down pat in your head. You've got to understand that, okay? The formula for calorimetry, and this is what you guys are going to be using this week in lab, so you're going to need this to complete your pre-lab. The formula is Q equals MS delta T. And I'm going to go through what each of these mean. You already know what Q is. Q is heat. What kind of units will we see for heat? Kilojoules, joules. Typically, it's going to be one of those, kilojoules or joules. Remember when we started off this chapter, we talked about calories, which we're all familiar with, and there's a conversion between joules and calories if you needed that. A little m, what does that stand for? You think? It stands for mass. When you're using this formula, mass needs to be in grams. So if you see it in kilograms, you've got to convert it to grams, okay? I'm going to skip S for just a second, and I'm going to talk about delta T. What does that delta mean? Change in. T is temperature, so delta T would mean the change in the temperature. How do we measure a change in something? It's something minus something. It's the final minus initial. So a change in temperature is the final temperature minus the initial temperature. It's important that you remember it's final minus initial. Because if you start at 0 degrees Celsius and you go up to 20 degrees Celsius, then the final minus initial is 20 degrees Celsius, right? But if you start at 20 degrees Celsius and you go down to 0, so 0 is your final, then what would your delta T be? Negative 20 degrees Celsius. So that is going to completely change the sign for Q and whether you're talking about an endothermic or an exothermic process. Okay? So remember, it's got to be final minus initial. What is S? That's a little s, and that stands for specific heat. And I'm running out of room on this slide, so I'm going to go to the next one. And define specific heat. So specific heat is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Specific heat has some funny units that we're not used to, but you will be now once I tell you. The units are joules per gram times degrees Celsius. Those are your units for specific heat. Look in your book on page 184. Because I want to talk to you for a minute about specific heat. Because y'all are familiar with things having different specific heats, and I don't think you realize it. Maybe some of you do. But if you look at page 184, table 5.2. So if you look at that table and you look at the specific heats, I mean, those are constants. Aluminum always has a specific heat of 0.900. So actually what y'all are going to do in lab Wednesday is I'm going to give you a metal. And you're going to have one of three metals. Maybe, I can't even remember the choices now. It's like lead and aluminum and chromium. I know one of them's copper. Anyway, y'all are going to do some experiments to calculate what is the specific heat of the metal you have. And then by calculating the specific heat, you can identify the metal you have. Okay, because specific heats are constant for certain metals. If you'll remember when we were dividing up the periodic table between metals and nonmetals, one of the properties that I named about metals is that they're good conductors of heat. What does that mean? Yeah, heat's able to pass through them easily. If you heat up a metal, if you put a metal object in a fire, whether it's a metal pan or a metal spoon, guys, can you touch it? No, you can't touch it because it gets hot, right? So what kind of handles do we have on our pots and stuff? They're usually plastic, right? A certain kind of plastic that won't melt. Pot holders, like those silicone pot holders. Y'all know what I'm talking about? Those flimsy plastic looking. Okay, we can use that to get things out of the oven, etc. So the fact that metal would get hot when it's introduced to heat means it has a low specific heat. It cannot absorb a lot of heat before it will start experiencing an increase in temperature. That's a characteristic of metals. So when we say they're good conductors of electricity, or, well, yeah, electricity too, but heat, that means as they absorb heat, they give it right back. So since I forgot to record all that explanation, I'll just let it record for a few seconds. So if you watch the YouTube video, it's there, but we'll record the next one.
You don't know what metal it is until you find out what
Exactly. You don't know what the metal is. If you knew it was aluminum, you could just look it up in the table. But you don't know that, so we can't look the specific heat up. We're going to have to calculate it. This is what you guys are doing in lab. You're going to make all these measurements. You're going to use a thermometer to record your temperature. You're going to use the balances to weigh the metal, etc. So what we have here is we have a Q for the water, and we have a Q for the metal. How are Q of the water and Q of the metal related to each other? They should be the same, but positive and negative, but opposite signs, right? If we can calculate how much heat the water absorbs, then we know how much heat the metal gave off. Because the metal is going to give its heat to the water. How would we calculate the heat that the water absorbs? That formula, heat. If we're wanting to know Q for the water, then Q for the water, hang on, I'm going to have to go to another page and just flip back and forth. For the heat that the water absorbs, I need the mass of the water times the specific heat of the water times the change in temperature of the water. And I'm not going to label all those with water because it would look like a really scary formula, and it's not. It's the same formula. But I just need, when I'm calculating Q for the water, I need to be sure all of my variables are for the water. What's the mass of the water? The problem tells me that the mass of the water is 120 grams of water, so there's M. What's the specific heat of the water? 4.184. Where'd y'all get 4.184? The table. Specific, right. Specific heat of the water is 4.184 joules per gram times degrees Celsius.
Like, how do you know that, that you're trying to do this to the water?
In order to calculate Q for the metal, or just for the metal, what am I wanting to calculate in this problem? It says the specific heat of the metal. in order to calculate the specific heat of the metal, well, I know that Q of the metal is equal to the mass of the metal times the specific heat of the metal, what I'm looking for, times delta T. Well, if you look at what you're given in the problem, you're given the mass of the metal, 9.42. You know how the metal changes its temperature, but you don't know how much heat that it gave off. So you're missing the Q and the S that you're going to solve for. So I can solve for the Q of the water, and then I know what.
The water and the metal are just going to be the same.
Exactly, just opposite sign. What's the delta T for the water? Where does the water start? The water starts at 22. The water ends at 28.2 for a delta T of 6.2 degrees Celsius. So then Q for the water, 3.11 times 10 to the third joules. Is that what y'all got? Yes. The Q for the metal is negative 3.11 times 10 to the third joules. So if I use this same formula, but I solve, what am I solving for, guys? Ultimately, the problem wants to solve for specific heat because it says calculate the specific heat of the metal. Can y'all rearrange that to isolate S on one side? Yes. If I take this formula and rearrange it, then isn't it S is equal to Q divided by M delta T? That's just isolating my variable, my S. What is Q? Heat for the metal. What is the heat for the metal? Negative 3.11 times 10 to the third joules. What's the mass of the metal?
9.42.
The problem tells me that the mass of the metal is 9.42 grams. What's the change in temperature of the metal? What's the final temperature of the metal? 28.2 is the final temperature of the metal. What's the initial temperature of the metal? 91.0. What's the delta T for the metal? Tell me again, negative
62.
negative 62 degrees Celsius. So what do y'all get for S? Ooh, huge number. Is that what you got?